Hi, everybody. It's Professor Mitchell. We're starting a new chapter today, Chapter 10 on the mathematics of finance, starting with section 10.1 on interest. Interest is the fee a bank pays for the use of money deposited into a savings account. The amount deposited is called the principal. The amount to which the principal grows after the addition of interest is called the compound amount or balance. If interest is compounded M times per year and the annual interest rate is R, then the interest rate per period or compound interest rate is I, which is found by taking R divided by M. For example, in this passbook that you see above, let's determine the principal, the compound amount after 1 year, the compound interest rate, and the annual interest rate. So the principal would be the $100 that was initially deposited. The compound amount after 1 year is the ending balance, $104.06. The compound interest rate can be found by noting that the first time interest was deposited, it was $1. $1 is 1% of $100, which means that the compound interest rate is 1%. And since the interest was compounded 4 times, that makes the annual interest rate 4%, which is 4 times 1%. Here are some common compounding periods. When interest is compounded annually, that means 1 time per year. Semi-annually is 2 times per year or once every 6 months. Quarterly is 4 times per year or once every 3 months. Interest is also compounded monthly, weekly, or daily. For a savings account in which the interest rate per period is I, the interest earned during a period is I times the previous balance. The new balance, B sub new, is computed by adding the interest earned during the period to the previous balance, B sub previous. Therefore, B sub new is equal to B sub previous plus I times B sub previous. By factoring out B sub previous, we get that B sub new is equal to 1 plus I times B sub previous. In this example, let's compute the interest and the balance for the first 2 interest periods for a deposit of $1,000 at 2% compounded semi-annually. Remember that semi-annually means M equals 2, which means I is 2 divided by 2% or 1, and we will always write that as a decimal when we're putting that in a formula, so 0.01. For the first period, the interest would be 1% of 1,000, which is $10, which means that the balance at the end of the first period is $1,000 plus $10, which is $1,010. In the second period, the interest is 1% of $1,010, which is $10.10. And that means B sub 2, the balance after the second period is 1,010 plus $10.10, which is $1,020.10. All right, next we'll talk about present and future value. Let I be the interest per period, P the principal, and F the balance after N periods. Then F can be found by taking 1 plus I to the power N times P. And equivalently, P can be found by taking F divided by 1 plus I to the power N. F is also referred to as the future value and P as the present value. In this example, if an account pays 6% compounded quarterly, first, let's find the amount in the account after 5 years if $1,000 is initially deposited. And then we'll find the amount that must be initially deposited if $3,000 is needed in 5 years. So using the formulas we just looked at, the period interest is I, which is 0.06 divided by 4, or 0.015. The number of periods total is N equals 4 times 5, so 4 times per year times 5 years, which is 20. All right, so for the first part, the present value is $1,000, which means the future value is 1,000 times 1 plus 0.015 to the power 20, which comes out to $1,346.86. If you have your calculator within reach, you should check to make sure that you're able to get this calculation to work. And then for the second part, F is 3,000, which means P would be equal to 3,000 divided by 1 plus 0.015 to the power 20, which is about $2,227.41. All right, that brings us to simple interest. Simple interest is earned only on the principal and is not compounded. If R is the annual percentage rate and N is the number of years, then interest is equal to N times R times P. And F, the future value, would be P plus N times R times P. Factoring out P, we get that F is equal to 1 plus N times R times P. P times the quantity 1 plus N times R. All right, so in this example, we'll calculate the amount after 4 years if $1,000 is invested at 5% simple interest. F is equal to 1,000 times the quantity 1 plus 4 times 0.05, which comes out to $1,200. And that brings us to effective rate of interest. The effective rate of interest is the simple interest rate that yields the same amount after 1 year as the compounded annual or nominal rate of interest. The effective rate is also known as the annual percentage yield, or APY, or the true interest rate. If R is the annual interest rate compounded M times a year, then remember that means that I is equal to R divided by M, which means that the effective interest rate would be 1 plus I to the power M minus 1. So in this example, we'll calculate the effective rate of interest for a savings account paying 3.65% compounded quarterly. So the effective interest rate would be 1 plus 0.0365 divided by 4, that quantity to the 4th power, and then subtract 1, which comes out to about 0.037. And that means that the effective interest rate is approximately 3.7%. All right, so to summarize, money deposited into a savings account earns interest at regular time periods. Interest paid on the initial deposit only is called simple interest. Interest paid on the current balance, that is on the initial deposit and the accumulated interest, is called compound interest. Successive balances of a savings account with compound interest can be calculated using B sub nu equals 1 plus I times B sub previous. Principal, which is the initial amount of money deposited into a savings account, also represents the present value of a sum of money to be received in the future. That is the amount of money needed to generate the future money. R, the annual rate of interest, is the interest rate stated by the bank and used to calculate the interest rate per period. M, the number of compound interest periods per year, most commonly 1, 4, or 12. We saw some other possible examples a few slides back. I, the compound interest rate per period, which is calculated using R divided by M. N, the number of interest periods total. And then F, the future value, compound amount, or balance, which is either found by using F equals 1 plus I to the power N times P, if you're using compound interest, or F equals the quantity 1 plus N times R times P using simple interest. And finally, effective rate of interest is the simple interest rate that yields the same amount after 1 year as the annual rate of interest. And that's found by taking 1 plus I to the power M and subtracting 1. And that's going to do it for section 10.1. We'll see you next time.